Cerebrospinal Fluid, or CSF. So this is abbreviated as CSF. The cerebrospinal fluid is derived from the blood by specialized capillaries in the brain. And these capillaries are called the choroid plexus. So you probably have heard of the blood-brain barrier, and this is part of it. The capillaries that serve the brain are not very leaky, and there are cells, glial cells, that surround these capillaries, including the choroid plexus, and prevent substances from getting into the brain and also into the cerebrospinal fluid. So in the past, for example, a good example of this that I've had experience with is Benadryl is an antihistamine that does cross the blood-brain barrier, and it makes you very sleepy. But the new antihistamines, like Claritin, do not cross the blood-brain barrier, and so they do not have an effect on your central nervous system. So looking at how chemicals and other things cross that barrier is important. When we look at the cerebrospinal fluid, it is constantly being produced, circulated, and reabsorbed. So when we look at where it is found in the meningeal layer underneath the arachnoid. So it's said to be in the subarachnoid space. It surrounds the brain, and it also fills up the ventricles in the brain, which are spaces in the brain, and it also circulates down the subarachnoid space and into the central canal of your spinal cord. So this is located in the underneath the arachnoid matter, which is one of the meninges that we talked about. Arachnoid, that's arachnoid space. And it is also in the ventricles of the brain, which are inside of the brain, and also in the central canal of the spinal cord. So it contains nutrients and other important things that help the brain, including oxygen, and it is circulated and reabsorbed here by what is called the arachnoid villus. So this is the arachnoid villus. So it is passed back into the circulatory system. When we look at where it is produced, we have these specialized capillaries located right here and here and here. That is producing it. And then here you can see its circulation. So it goes down and into the spinal cord, it comes back up, and then it goes into these arachnoid villi, where it then gets taken back up by the blood system, so the circulatory system. So it is continually produced. We'll write that down, circulated, and reabsorbed. One interesting thing about alternative medicine, you might have heard of cranial sacral therapy. And this is the idea that if through manipulations of your head and your spine, you could actually get this fluid to circulate better. And so this is not scientifically proven, I don't believe, but there are people that do cranial sacral therapy, specifically like on people that are paralyzed, in order to get the cerebrospinal fluid to circulate better. The other interesting thing that you might have heard of is the leaking of the CSF, sometimes when people have an epidural. So epidurals are sometimes given to women, oftentimes when they're in labor, and sometimes they can accidentally puncture the dura mater and go into that subarachnoid space, and the cerebral spinal fluid can leak back out. And when that happens, when we don't have enough cerebral spinal fluid, we, for example, are in a lot of pain, and people that have leakage of the cerebral spinal fluid can't sit up because it causes the movement of the cerebral spinal fluid out of the brain, which supposedly creates incredible headaches. And so then they have to do a patch. So they actually have to put more, um, not synthetic, but derived cerebral spinal fluid back into, it's like a blood patch, back into the subarachnoid space to get that back up. Sometimes people get what is called hydrocephalus. So this is water on the brain, hydrocephalus, and this is where you do not have the reabsorption. So you have too much cerebral spinal fluid. So it's not being reabsorbed properly. In children, this, because of their fontanelles and that their skull bones are not completely fused, this can cause them to have huge heads because it expands. And it's actually less dangerous in children because the bones expand. But in adults, if you have too much cerebral spinal fluid, it can actually put pressure on the brain and can be very dangerous. And so they would have to put a shunt into that space to shunt some of that extra cerebrospinal fluid out of that area so that there is less pressure being put on the brain.